Hello friends, in this video we are going to discuss about the value of electron and hole concentration inside the semiconductor when the conductivity value is minimum. That means we need to calculate the electron and hole concentration inside the semiconductor when the conductivity value of that semiconductor is minimum. So as we know, the conductivity of any semiconductor, we denote it as sigma. So this is the conductivity, and we know that the conductivity value is equals to n q into mu n plus p q into mu p, where the n value is the electron concentration, q value is the electronic charge, that is 1.6 into 10 to the power minus 19 coulomb, and p value is the hole concentration, and mu n and mu p is the mobility value of electron and hole respectively. So this is the equation for the conductivity of an semiconductor, and in this case we are assuming that this semiconductor for which we are going to calculate the electron and hole concentration is intrinsic. So using the mass action law, we know that the hole concentration P can be written as Ni square divided by N, where Ni value is the intrinsic carrier concentration of the semiconductor. So from the first equation, if I denote it as equation number 1, so from equation number 1 we can write that sigma value is equals to n into q into mu n plus p value. So this p value, from the mass action law, we will replace this value in this equation, so it will come as Ni square divided by n into q into mu p. Now we have to find the condition when the conductivity value is minimum. So we know that from the maxima minima rule, the conductivity value will have a minimum value at that condition when d sigma by dn, that is the first derivative of sigma with respect to the electron concentration, will be equals to 0. So from this condition we can find the value of sigma min. So for that case we have to derivative the first equation of sigma. So from this, if we find the value of d sigma by dn, we can write it as q into mu n plus minus 1 by n square into ni square into q into mu p. So this is the value of d sigma by dn. Now to find the conductivity minimum value, we have to put the d sigma by dn equals to 0, and we have found the value of d sigma by dn. That means 0 is equals to q into mu n minus ni square divided by n square into q into mu p. So from this equation we can find the value like this. If we want to find the value of mu n, then mu n can be written as, from this equation, as ni square divided by n square into mu p. So this is the value of mobility of the electrons when the conductivity value is minimum. But we need to find the value of electron concentration, that is n. So from this equation we can find n will be equals to ni root over mu p divided by mu n. So in this way we can calculate the value of electron concentration when the conductivity value is minimum. So we can say that this is the electron concentration value when sigma is equals to minimum value. Now we need to calculate the hole concentration also. For that case, we know from the mass action law that the hole concentration value is equals to ni square divided by n. Now we know the value of n for sigma minimum. So if we put the value of this n in this equation, then I can write it will be ni square divided by ni root over mu p by mu n. So this is the hole concentration value of the semiconductor when the conductivity value of that semiconductor is minimum. So we can write that it is hole concentration value when sigma value will be minimum. So in this way we can calculate the value of electron and hole concentration when the conductivity value will be minimum. Thank you.